In question number 5, the square roots of -1 -4 root 5 iota can be expressed in the form x plus iota y. By first forming a quartic equation in x or y, we have to find the square roots of -1 -4 root 5 iota. Now, this is a complex number 1 -4 root 5 iota, and the square root of this number will also be a complex number, which is x plus iota y. Now, to find the square roots, we'll whole square both the sides. So we'll get, if we expand the right hand side, so this will remain as it is without the square root sign. And this will become x square plus 2xy iota, and then plus iota square y square, which will be equals to minus y square, as iota square equals to -1. So now comparing both the sides, the constant term on the left hand side is -1. On the right hand side, that is x square minus y square. And then the coefficient of iota is 2xy. And on the right hand side, that is -4 root 5. Now we'll use these equations to form a quartic equation, the quartic equation, and then find the values of x and y. So let's say x is equals to -4 root 5 upon 2y. This will cancel out. So x would be equals to -2 root 5 upon y. Now in place of x, we'll substitute this value. So 1 minus 1 would be equals to -2 root 5 upon y whole squared minus y squared. Expand whole squaring, we get -1 is equals to, so 4 into 5, that will be 20 upon y squared minus y to the power 2 again. Taking the LCM, so this is multiplying by y square. You will get 20 minus y to the power of 4 divided by y squared equals to -1. Cross multiplying, we'll get minus y squared is equals to 20 minus y to the power of 4. Making y to the power of 4 positive, we'll get y power 4 minus y squared minus 20 equals to 0. Now, this is a simple quadratic equation. We can solve it like a quadratic equation by midterm breaking. We can write it as y power 4 minus 5y square plus 4y square minus 20 equals to 0. Taking y squared common, we'll get y square minus 5 plus taking 4 common, we'll get y square minus 5 equals to 0. So we'll get y square plus 4 equals to 0 and y squared minus 5 equals to 0. Now, as x and y are real numbers, so y square equals to -4 will not be positive, as the square root of a negative number is not possible if it is real. And y squared is equals to 5, so y would be is equals to square root of 5. And when we square root, we can give both the positive and negative values. So, or we can even keep it as root 5, but we know that the complex square roots are conjugates of each other. So now we know that 2xy is equals to -4 root 5. So we can now write it as 2x into y. So y is root 5 is equals to -4 root 5. So now cancelling root 5, x value would be equals to -2. So one of the complex values would be -2 and the y value was taken as plus root 5 iota. So this will be -2 plus root 5 iota. And to find the other root, we'll substitute minus root 5 into the equation. So we will get 2x into minus root 5 is equals to -4 root 5. Root 5 cancels, negative cancels, the x value would be 2. But so the other square root would be 2, and the y value was minus, so that will be minus root 5 iota. So the two square roots would be -2 plus root 5 iota and 2 minus root 5 iota. Just one correction, what I said, I think I said they're complex conjugates. Well, not square roots. The root of a complex number, like if we find this, we solve it through quadratic formula, then in that case, they are complex conjugates when we are finding the roots, not the square roots.